Energy is the operation, the flux or activity of any being, as the light of the sun is the energy of the sun, and every phantasm of the soul is the energy of the soul. The first recorded definition of the term energy in English. Henry Moore, 1642.
Shake me down, not a lot of people left around. I'll keep my eyes fixed on the sun.
Solar power is at the forefront of alternative energy exploration. Attempts at harnessing its immense and endless energy are being researched and utilized globally. But I wanted to take a look at solar power more intimately and learn about its potential on the individual scale. This led me to the prime example of solar ovens. Solar ovens cook by using the sun's infrared and UV rays, which carry heat, a reflective or magnifying material, and the science of heat absorption by dark color. Insolation and reflection traps the energy, heating up a small space, so it is able to cook meat, veggies, bread, and other foods. Solar ovens are proven safe, highly effective, and completely sustainable in the right conditions. Therefore, it's seen more development in the recent years. Perhaps the best thing about solar ovens is the fact that they're so easy to make. Let me show you how to make one, and what I learned from making my own. You'll need two boxes, one slightly larger than the other. The ones I used were 8 by 12 inches and 12 by 14 inches. But most importantly, one just has to be able to fit inside the other. You'll need a dry, insulative material. I just used newspaper, aluminum foil or some other reflective material. You'll also need something to cover the top of the oven, but also let light through. Some people get fancy with plexiglass or sheet glass, but for my intents and purposes and for cost reasons, I just use plastic wrap. You'll need to make your oven black for maximum heat absorption. I actually used a heat-resistant black spray paint for painting grills and stuff. If you can't find this, you run the risk of making your food toxic from the paint fumes. So if you can, it's really good to get a barbecue kind of paint where it can withstand high temperatures when dry. Having a thermometer is also important, so you can keep track of how hot your oven is getting and how hot the food is inside. So I used 2 meat thermometers to get the average heat inside the oven. And lastly, you'll need a box cutter and tape or some other adhesive material. First, you'll need to paint your boxes black. Most importantly, the lid of the bigger box and the bottom inside surface of the smaller box. When dry, coat the inside walls of the smaller box with adhesive material. This could be glue or tape or whatever you have. And then line it with aluminum foil. Next, set the smaller box inside of the bigger box and line all the edges with newspaper or whatever insulated material you have available. Measure the space between the walls of the 2 boxes. In other words, the width of the insulated material. Then on the lid of the box, make a marking of the same width. That way we can more accurately cut out the top to fit the opening inside. Now your 2 shoe boxes should already start to be looking like an oven. Taping the flap that we just cut, line it with the aluminum foil or reflective material. Next, tape the plastic wrap on the inside of the opening you just cut. The final product should look like this. Don't forget to put the thermometers inside too. Then just situate it in a sunny, warm spot outside and we can see if it works. As you can see, it's a pretty nice day here in Fond du Lac, Wisconsin. Few clouds, but we're still getting a lot of sunlight. As you can see, I placed it in a way so it gets the maximum amount of sunlight on the panel there, and there's a little shadow. Some people suggest situating it so there's more of a shadow on the side where the sun will be moving. So if you're going to keep it out here for longer periods of time, when the sun moves, it'll still be getting maximum sunlight. So, checking the thermometers here, it looks like this one reads 140 degrees Fahrenheit. And then just to make sure that those are matching up, it looks like this one's reading the same thing. And the temperature is now reading 160. So it's a little bit, heating up a little bit more slowly, but still pretty quick considering. In half an hour it's jumped up quite a bit. So now on my little makeshift plate here out of aluminum foil, we have a hot dog. We're going to put it in our solar oven and see how quick we can get it to cook. After about 20 minutes in the oven, I found that the internal temperature of the hot dog had leveled out at about 150 degrees. I would call my little experiment a tasty success.
Oh, Mr. Sun.
Solar ovens have many benefits. First of all, it's low cost. The total materials for this project cost under $10. Also, there are 0 greenhouse gas emissions because it does not burn any type of fuel. No biomass, no fossil fuels, nothing. The design is reusable and there's plenty of room for technological improvements. Solar ovens also have a lot of cons. Obviously, it's very time consuming. It relies heavily on climatic conditions that you're trying to cook in. It has its limitations as far as temperature ranges, and it also requires detailed accuracy as far as positioning and angle of reflection. My overall conclusion about this technology is that it has a lot of potential. Maybe not necessarily potential that could be utilized in the United States, but in other countries worldwide. Places where there isn't readily available fuel or biomass that can be burned, and that way so everyone can have a hot meal.